Hey guys, today we are going to talk about something called multiplicity. So multiplicity is going to look at how different exponents on different factors are going to affect how the graph looks at the zero that you get from that factor. So we have a couple of different equations here and we have a few different shapes that we're going to look at on how it could possibly look at that zero. So the first thing that you're going to do for both of these equations is just graph it, and it has like a specific window here, so I went ahead and graphed it in my calculator, and this is how the graph of number 1 looks. So we have the 2x squared times x minus 1, and it creates this graph. So the first thing I'm going to do is I'm just going to sketch this graph on my little grid here. So how it looked is it came up and it hit 0, and then it turned around and then went back down and it went through +1. So it looked something like that. And then I also want to talk about the equations because each factor leads to one of the zeros that's on here. So the 2x squared, that's going to give you the 0 or the x-intercept. Oops, I'm sorry. That's going to give you the x-intercept of x equals 0. And then the x minus 1, if you guys remember from some of the stuff we were talking about previously, to find like what 0 that creates, you would set it equal to 0 and then solve for x. And so the 0 or the x-intercept that creates is at x equals +1. So then over here, it's talking about the degree and the shape. So the degree, if you guys remember, refers to the exponent, and it's talking about the exponent on each of the factors that led to these zeros. So if you look on the graph, there's not a 0 at x equals -1, so we're just going to cross that one out. We're not worried about that one for this problem. But when x equals 0, that's where it comes up and hits the graph and then goes back down. So the shape, the three shapes that we're going to look at are called a cross, where it just goes straight through the x-axis, a bounce, where it hits the x-axis and then turns around, and then a wiggle, where it comes up to the x-axis and levels out for a second, and then it continues going through. So the shape right here that we're talking about is where it comes up and it hits the x-axis, but then it turns around and goes back down. So that shape is going to be considered a bounce. So that looks the most like this shape here in the middle. And then we're also looking at where x equals 1. So that's where it crosses right here. And remember, you're only really looking where that 0 is. You're not looking at the whole shape of the entire graph. Right now, you're just looking inside this blue circle that I just drew. So that shape most resembles this first shape of a cross. And so then we need to look at the degree or the exponent that each of these factors had. So the factor for x equals 0, the exponent up here is 2. And then the factor for x equals 1, there's no exponent. And so if there's no exponent, then the implied exponent is just going to be 1. So then if you want, you guys pause here and you can try to do number 2 on your own and then unpause and we can go through the rest of it together. And I'm going to go ahead and get that one in the graph for us as well. Okay, so if you look over to our calculator, this is the graph that we're going to be using. So I'm going to go ahead and sketch that on my graph here. So it came up to -1 and it kind of leveled out for a second and then it went up and came back down through 0. So that's a kind of poor drawing, but it looks something like that. So then I'm also going to look at my factors to see which zeros each of them gave me. So the -6x, that's going to give me the x-intercept of x equals 0. And the x plus 1 is going to give me the x-intercept of x equals -1. And because remember that it's like x minus each of these zeros. So that's why it's going to be the opposite of whatever is in the factor. So then if I'm looking through where my zeros are and all of that, I notice there's not a 0 at x equals 1. So I'm not going to worry about these boxes. And so then I just need to look at x equals -1 and x equals 0. So at x equals -1, we're just looking at this portion of the graph right here. And so it kind of like came up to the x-axis and leveled out and then kept going up. And so that shape is going to be a wiggle because it kind of just like wiggles through that 0, if you can imagine that. So for at x equals -1, the shape we're going to say is a wiggle. And then at x equals 0, we're looking at just the behavior in this blue circle here. And that just goes straight through that x-intercept at x equals 0. And so that's going to be a cross. So then looking at the degree of each of these, or the exponents on their factors, for -1, for that factor, the degree is 3. And then for 0, it doesn't have an exponent. So like we said earlier, the implied exponent is going to be 1. So then we're going to use this to kind of like answer some different questions about how each of these exponents is going to affect our graphs around the zeros. So the first question is, what is the exponent on a 0 that bounces at a 0 or bounces on the x-intercept on that axis? So I'm going to come back up here and I'm going to look for where does it bounce. And this is the only bounce that we have, and the exponent on that, or the degree, was 2. So then I want to know what's the exponent that causes a wiggle through the 0. So my only wiggle is right here, and my exponent on that is a 3. And then the exponent that causes a cross at 0, and so both this one and this one are a cross, and for both of them the exponent is 1. And then, so definitely write these down. You're going to want to know that the exponent that causes a bounce is 2, a wiggle is 3, and a cross is 1. And then the exponent on a 0 is going to be called the multiplicity, which is kind of what we were talking about at the very beginning. So you're going to want to write down this word as well. That's going to be what causes each of these bounce, wiggle, and cross shapes. Okay, so then on these couple of examples, it gives us the graph and it gives us all of this information about where there's a wiggle, what the degree is, and all of that stuff. And so what we're going to do is we're going to try to write the equation. So the first thing that I need to write the equation is what my zeros are. So I'm going to look at where this graph crosses the x-axis. And I see the first time that happens is at x equals -1. And it happens again at x equals +1. So then I want to write out these factors. So for my factors, I'm going to have x minus each of my zeros. So I would have x minus -1, and I would have x minus +1. And so then if I am kind of simplifying that, then the x minus -1 is going to be written as x plus 1, and then my x minus 1 is just going to stay x minus 1. And so then I'm going to look on my table over here, and I have where x equals -1, it says the degree is 3. And then if you look over here, it also wiggles through -1. So then that means I need an exponent of 3 on that factor. So for x plus 1, I just need to put a 3 on the factor. And then at x equals +1, it tells us there's a bounce and the degree is 2. If you look on the graph, you can see the bounce, which means the multiplicity is 2. And so then you can go ahead and put a 2 on that factor. And then why don't you guys pause here and try to write number 5 on your own and see if you can get it. And if not, then when you unpause, I'll go over it as well. So again, the first thing I'm going to do is find where each of my zeros are. So it crosses here, it bounces here, and it crosses again here. And so that's at x equals -1, x equals 0, and x equals +1. And so then I want to write out each of my factors from that. So my first one is x minus -1, x minus 0, and x minus 1. And so then I'm going to kind of simplify that. So my x minus -1 is going to become x plus 1. X minus 0 is just going to be x, and typically that would be written in the front of your equation. So I'm just going to put an x up there, and then I would pull down my x minus 1, and that's going to stay the same. And now the only thing left to do is start looking at all of these multiplicities. So at -1, where x equals -1, it just crosses through. That means that's going to have an exponent of 1. And if it has an exponent of 1, you don't really have to write it in. And then, so you can just leave that factor as x plus 1. The next one is at x equals 0, and it bounces there, so that means our degree or exponent is going to need to be a 2. So this regular x up here, I'm going to come up here and put a squared on that, because that's going to create that bounce shape that happens on the graph. And then my last one, at x equals +1, that's my factor x minus 1. The exponent should just be 1. So you can just leave that factor as is as well. So then something else you may see happen is when you're asked to sketch a polynomial and it gives you the zeros and it tells you like the multiplicity at each 0. So like on -6, it doesn't actually say what the multiplicity is. So if it doesn't tell you, that means it automatically is going to have a multiplicity of 1. It's kind of just like those exponents. If it doesn't have the exponent, then it's implied that it's 1. So the first thing I'm going to do here is I'm going to actually plot my zeros on the graph. So I have a 0 where x equals 3. So I'm going to go on the x-axis to where x equals 3 right here. And then I have another 0 at x equals -6. So I'm going to go on the x-axis to x equals -6. And then the only other thing I need to do is I need to know what the shape of the graph is at each of these points. So where x equals 3, it's a multiplicity of 2, so that means it's going to bounce. And where x equals -6, it's a multiplicity of 1, so that means it's going to just cross through the graph. So I'm going to go ahead and try to sketch something that works for this. So I'm going to start down here, and I'm going to cross through -6, and I'm going to come back down to where x equals 3, and I'm going to bounce back up away from that x-axis. So this is one version of a graph that you could draw. However, this isn't going to be a unique graph. There is another answer that would also be correct. So if I had started up here, for example, and I came down and I crossed through where x equals -6, and then I came back up and I bounced where x equals 3, then that would be another answer that would be possible. The only time that it would not have like two different types of graphs is if it tells you the end behavior or if it gives you like more information, like a maximum or a minimum or something like that. But in this scenario, since it doesn't tell you any of that, you're just going to have these two. They're not going to be unique. As long as you have one of these two graphs, you would get that answer correct. So then I want you guys to try this one. There's 3 different zeros on this one, and so just pause the video on a separate sheet of paper. Just try to sketch what you think it would look like, and then unpause when you're ready to see me go through it. So my first 0 that it gives me is at x equals 6. So I'm going to go ahead and plot that. And then I have one at x equals 0, so that's right here at the origin. And I have another at x equals -4. So then I just need to go through and figure out what's the shape on each of these. So for x equals 6, that means a multiplicity of 3 means we're gonna wiggle through that 0. where x equals 0, it doesn't tell us the multiplicity, so that means it's 1, which means we're going to cross through. And at x equals -4, the multiplicity is 2, which means we're going to bounce. So we have all three shapes in this graph. So I'm going to start at the bottom, and I'm going to come up to where x equals -4, and I'm going to bounce through that 0. Then at x equals 0, I'm supposed to cross through, and at x equals 6, I'm supposed to wiggle. So that means I'm just going to level out and then keep going down. So that's going to be one version, and then if I had started above the x-axis, I'm going to go ahead and draw out what the other version would be. So this time I'm just going to come down to -4 and bounce away. I'm still going to cross straight through our 0 and then wiggle through where x equals 6. So this would be the other version of the answer to this type of problem. Okay, so one more thing that you might be asked to do is to use the zeros to write an equation for the graph. So if you're going to be using the zeros, then the first thing that I would recommend doing is finding all of the zeros. So we're going to look everywhere that we cross through the x-axis or that we bounce. And so that's going to happen at x equals -1, at x equals 0, and at x equals +2. So then if you guys remember, to write the factors, we're going to do x minus each of these zeros. So I would have x minus -1, x minus 0, and x minus 2. And so then if I am simplifying these, then I would have x minus -1 is just going to be x plus 1. X minus 0 is going to just be an x. And like I told you guys earlier, that if it's just an x, you would typically write it in the front. And then the x minus 2 is going to stay the same. So now the last thing we need to do is go through and put our multiplicities or our exponents on these. So at x equals -1, you can see it just crosses through that axis right there. So that's going to be a multiplicity of 1. So that means you wouldn't necessarily need to write the exponent there, but if you were going to, then it would be just a 1. And then for 0, it crosses through again, so that also has a multiplicity of 1. So same thing, if you wanted to write the exponent of 1, you could, but you don't have to. And then where x equals 2, it comes down and hits the axis and then goes back up. So that's going to be a bounce, and a bounce has a multiplicity of 2. So then on that last factor, x minus 2, we're going to go ahead and put an exponent of 2. And then this would be our answer. So then I have one more example like this. So I want you guys, again, to just pause and try to do this on your own and unpause when you're ready to see it worked out. So the first step, again, is going to be to find all of my zeros. So I have a 0, x equals -1, x equals +1, and x equals 2. So I'm going to write all of those out. We have -1, +1, and 2. So then I'm going to use that to write my factors. So x minus -1 is just going to be x plus 1, x minus 1, and then x minus 2. So that's just our x minus each of these zeros. And the only other thing we need to do is go through and put our exponents on there. So at -1, it just crosses straight through the graph, so our multiplicity is going to be 1, and we don't have to put an exponent on there because it would just be a 1. At x equals +1, it comes down and hits the x-axis and then bounces back up. So since it bounces, the multiplicity is going to be 2. So that's my factor, x minus 1 gets an exponent of 2. And then where x equals 2, it just crosses through again. So that's another multiplicity of 1. And whenever it's a multiplicity of 1, we don't have to write that exponent there. So this would be the equation that we would use for our graph. So I think that sums up everything that you should know about multiplicity and zeros and all of that. So just let me know if you have any questions about anything in this video today.